the IFR Research Center, Osaka University, Singapore Management University, my fellow researchers from the different Southeast Asian countries, and the global community of educators and researchers. A pleasant day to everyone. I'm Frank A. Fran, a graduate student of Ateneo de Manila University and the faculty of Romblon State University. Today, we are here to present our paper entitled Development and Evaluation of Frankards, a Manipulative for Teaching Probability. My co-author for this study is Dr. Catherine P. Vistruyu, Professor of the Department of Mathematics and Program Coordinator for Mathematics Education at Ateneo de Manila University. Mathematics always play a vital role in education, hence teachers handling these subjects should therefore be proficient in teaching and be equipped with the essential skills and strategies. Knowing the Department of Education's current curriculum framework enables the teacher to develop and to adapt lessons that is suited to the needs of the learners. As pointed out by the UN SDG Platform 2022, more than 50% were not achieving minimum proficiency levels in mathematics. In the context of the Philippines, 37.30% achieve at least a minimum proficiency level in math. Hence, the United Nations, through its Asia and Pacific Progress Report 2019, pointed out that there is a need to accelerate progress to achieve the SDG 4's targets, which include numeracy. However, there is some hesitation whether improvement in numeracy can be achieved based in the 2030 targets. With this in mind, the researchers intend to contribute into the achievement of the SDG 4's goals and targets through this research. Specifically, this study sought to answer the following research questions. First, what are the baseline data that can be gathered in relation to the development of instructional material in terms of teachers' needs, difficulties, and suggestions, and students' needs and difficulties? Second, what are the experts' formative evaluation on the developed instructional manipulative in terms of Factor A, the content, Factor B, other findings, and Factor C, additional requirements for manipulatives. Here are some of the salient literature for this research. As pointed out by Buhler et al. 2016, given the abstract nature of mathematics, teachers should engage learners through visual approaches. It was also emphasized by Holmes 2013, Larby and Occhier 2014, and Uribe Flores and Wilkins 2017, that manipulatives can aid in enhancing students' achievement and attitude towards mathematics in long-term basis. Hence, Su and Moyer-Pakenham, 2007, assert that manipulatives, concrete or virtual, can contribute to students' learning and encourage relational thinking and algebraic reasoning because of its positive effects. This study is anchored on Johnson and Lacob's experiential realism, as cited by Ramirez 2012, which is based on the assumption that there is a reality out there, and that the purpose of our perceptual and cognitive mechanisms is to provide representation of this reality. According to this, if we want to set our students in a meaningful context, they should be placed in the reality they live in. In order to do it, we must bring the reality out there inside the classroom. This study is also anchored on realistic mathematics education, where the context and real-life experiences of learners are being utilized as starting points prior to the learning of abstract and formal concepts of mathematics. It also gives opportunities to learners to reinvent their own understanding of the mathematical content and processes of horizontal and vertical mathematizations. So these two theoretical constructs are the basis of how the study was developed and conceptualized. So based on this experiential realism and realistic mathematics education, we try to conceptualize an instructional material based on the context and needs of students. Generally, this study was conducted using the development research design anchored on the ADDI model by Branch 2009. But specifically, this research has two phases. So based on the ADDI model, the study has two major phases, as I have mentioned: the gathering and evaluating of the baseline data, and the development and evaluation of the manipulative development. In the first phase, the participants were 35 students and 15 mathematics teachers. Answer questions using the baseline interview schedule by Pitalvero 2013 as cited by Maliksi et al. 2019. The data was collected from the structured interview and questionnaire responses, and the data were analyzed using person. For the phase two, the development evaluation of the manipulative develop, and then that follows the evaluation of 26 grade and mathematics teachers. They were to evaluate the manipulative using the evaluation rating sheet for manipulative as prescribed by the Department of Education. To evaluate the evaluation ratings from the mathematics teachers were gathered and statistically analyzed. So here are the results and discussions. So this first figure shows that out of 35 students that evaluated based on the baseline data that we have gathered, the 40% of them considered statistics and probability as the most difficult content area based on the K-12 basic education curriculum for grade and math. This implies that majority of the students have difficulties in understanding concepts that are related with combination, permutation, probability, and other associated. So based on the given figure also and the following figure, it can also be noted that 17 or 48.6% of the students preferred to learn mathematics with the aid of manipulatives when asked on the preference of their instruction. This was followed by the lecture and the group activities. So students were also asked on their perception on the use of the module as the sole instructional material. So you see the only available instructional material provided by the Department of Education for teachers are just the learning modules. The students were asked if they agree whether the use of the module as the sole instructional material is okay. So the graph showed that 77% of the students disagreed that the learning module should be the only instructional material to be used in learning the different lessons. So on the other hand, 23% agreed. This notes that learning the mathematical concepts, the students want to be exposed with its real life applications with the aid of other instructional materials. As what we have done in the students, we also ask teachers and ask for their perceptions on what particular content area in grade in mathematics they consider to be the most difficult to teach. With the same response from the students, they have also identified, or 80% of them identified statistics and probability as the most difficult content area for grade in mathematics. Hence, this area needs cultivation and enhancement of their foundational knowledge. And they were also asked, or teachers were also asked if what particular content area needs an intervention material. And based on the contents of the K-12 basic education curriculum for mathematics 10, 66.7% of the teachers perceive the statistics and probability as the content area that needs an instructional innovation and instructional material. This includes, for instance, manipulatives. This was followed by patterns and algebra, then geometry. This is evident since it can be noted that patterns in algebra have specific instructional materials or manipulatives for them to be used in this example tiles. On the other hand, geometry also specifically have different sets of instructional manipulatives and materials that can teachers were also asked if there are available instructional materials for these difficult lessons, as Kadin pointed out. They have identified statistics and area. So the chart shows that 73% of respondents stated that there is no instructional manipulative available for subjects such as statistics and probability. So this may be one of the reasons why students and teachers find it difficult to understand. Thus, there is a need to create and to develop interventions. So this is where the development of the instructional material for mathematics, specifically for statistics and probability, emerged. So here, the authors developed the Frankards. So here's the developed manipulative sample deck of Frankards. It is a set of 56 cards specifically crafted to assist teachers in teaching probability. Unlike the regular deck of cards, Frankards was uniquely designed to use polygons as the suits instead of the suits in a standard deck of playing. The use of the standard deck of cards has been banned in schools to prevent students from engaging in gambling activities. That's why the author decided to create an instructional material that is more mathematical than the standard deck of cards. So here's a sample application. So for instance, in a standard deck of prank cards, we wanted to find for the probability of getting a blue card or an arithmetic card. So here, we have a blue card, which is composed of 28 cards, and the arithmetic cards, 36 blue polygons from 2 to 10. And so if we're going to apply the equation for non-mutually exclusive events, so we have this equation here. So the probability of A or B is equal to the probability of A plus the probability of B minus the intersection of probability of A and B. So the probability of A or B, we have here 28 over the total number of cards is 56, plus the 36 over 56 minus 18 over 56. Sense about probability of getting a blue card, an arithmetic card, and probability of getting intersection of blue card and an arithmetic card. So by applying the operations, the probability of A or B resulted to 23. So that's how we apply the concepts of prank cards, or that's how it works. So this card was developed and then uh, ran some preliminary simulations, and then were subjected to teachers' evaluation. So the succeeding evaluation reflects on the evaluation made by teachers on instructional material design. So this was based on the evaluation rating sheet prescribed by the Department of Education. So here, the first table shows the experts' evaluation of the manipulative in terms of content. So that's the factor A. It generally shows that the manipulative is uh, formatively evaluated as very satisfactory in terms of this implies that the manipulative has the requirements prescribed for manipulative as to the content. Specifically, the evaluators have given the manipulative perfect rating for the first two indicators, including the ninth indicator. And we have not given perfect scores for the other indicators. Still, the descriptive interpretation for these indicators are very satisfactory. So this means and implies that the instructional material developed as to content has satisfied the prescribed. Sense the evaluation of experts on the manipulative in terms of other findings. This is the factor D, where it shows that that conceptual errors, factual errors, grammatical and or typographical errors, and other errors are not present in their evaluation, which is also a good evaluation. And lastly, for table three, based on the evaluation on factor C, which is an additional requirement for manipulative, which specifically talks about the instructional design and the technical design of the manipulative developed. Table 3 presents the evaluation of the validators and evaluators of the instructional material based on given design, and it was rated very satisfactory. Specifically, the evaluators formatting says that the manipulative is safe to use, achieving rating of 4. So, and the other indicators also receive a very satisfactory rating, which is a very good rating. This implies that as to the instructional and technical design, the manipulative passed the prescribed criteria. So in summary, the figure shows the ratings of evaluators across the areas of evaluation. It shows that the earned points for every factor is above or equal to the required minimum requirements or required points reflected in the graph. So this implies that the manipulative generally pass the requirements prescribed by the Department of Education for the manipulative. So based on the results and discussion, we can conclude that the baseline data gathered showed that there was a need to develop an instructional material to assist teachers in teaching the least mastered competencies, specifically under the statistics and probability. So also based on the baseline data that was gathered, most teachers and students found statistics and probability as the most difficult area in math. This resulted to the development of instructional material that focuses on statistics and probability. So then the instructional material developed was evaluated, and it can be inferred that the manipulative developed passed all the prescribed criteria set by the Department of Education. Selection of the appropriate and quality instructional materials. So because of that, we have the following recommendations. So the utilizations of instructional material is highly recommended. It's suggested to be the next phase of the study. After testing its effectiveness, it can be recommended also that for dissemination to teachers, especially those who are handling subjects that deal with probability and statistics. And also application for copyright is highly recommended by the evaluators before its dissemination and utilization. So since its development up to now, Frankards received recognitions from Romulan State University as the best paper for development category in August 2019, and a National Special Merit Award from STEM Hub Philippines during the National Science and Engineering Fair Philippines in February 2019. And also as of this time, it had received the copyright accreditation and by the National Library of. So here are my references. Together with my co-author, Dr. Catherine Pipis to you, we would like to extend our heartfelt thanks to International Academic Forum and Singapore Management University. Thank you for your attention and have a great day.